Hey everyone, in this video today I'm going to demonstrate how to properly set up a basic pulley joint and kind of show you what some of the local variables that are, or the public variables that are available in the pulley joint definition, and just get a simple little sandbox thing set up so you guys can see what each setting does and understand how each body attached to this pulley joint is influenced by any other body and how they react and whatnot. So I think the best thing to do would be to show you guys this little drawing here I put together. You'll notice that I have a box here and a box here. Those are going to signify some box bodies, which we have made before. If you don't know how to do that, I definitely recommend checking out maybe one of my other videos or looking up how to create a polygon shape and setting it as a box and putting it in your Box2D world. Just a general gist of what you need to do for that. Otherwise, we'll call this body A on the left here, and we'll call this body B on the right. And what you see here, this line that's kind of overhead of them, is what is going to be a visual representation of our pulley joint. Now, what joints are known for is attaching two bodies in a special way, and each joint has a special property about them. And the pulley joint is definitely one of the more unique ones out there, beside the prismatic or distance joint. This one has a defined length for each side for which the body is each body is attached, and there's also this intermediary arm that you'll notice kind of ties between these two nodes here. Now, in the Box2D debug renderer, you're not going to see these circle nodes. You're just going to see a straight line like here, and it'll kind of come up and just be like that. This is what we're going to be setting up today. However, these one thing to note is these lengths that these arms are attached to each body are very unique in how they'll define how your pulley joint will act when forces will interact with the bodies. So let's say this is of length 3, just to give an example real quick, and this is of length 3 as well. If this body is influenced by some outer force or is told to move up by applying a force to its center, so we could say that this body will be pushed upward all the way to this joint. Now, with pulley joints, that's not very ideal, of course, and I'll explain why later, but let's, for the sake of this demonstration, say that this joint, or this body, moves all the way up to this point. Now, this line will look like it becomes consumed by the body as it moves up. But on the right, as this is moving up, this body will move down because it is pretty much like, you could think of it as it's pushing this line here through this pipe and funneling it right back out here. And the unique thing that I was talking about, the property about these two arms is, let's say this is arm A and arm B. Any arm can only be extended to the extent of arm A plus arm B. So that is a constant property that does not change unless you change the length of the arms programmatically or otherwise. So that's just one thing to keep in mind. So if this one is up here, then this body will be extended, depending on the angle that it is currently oriented at, by A arm plus B arm length. So it'd be extended by 6 world units. So that's just kind of how a box or a pulley joint will work. It's essentially, as you'd assume a pulley is, a rope around here is just tied around here, and if this box is lighter than this box will weigh this one down and pull this one up. So that's essentially how the pulley will work. So to kind of make you understand how it works in the Box2D world, this node here and this node here are called ground anchors. Now, they're a little bit different than what you've probably seen in previous videos called local anchors. Local anchors are relative to the body that the joint is being attached to. So a local anchor typically starts at 0, 0 of any Box2D body that you give it. or a fixture, sorry, and ground anchors will specify where this line will be placed and how it will be oriented. So like you'd put it 3 units above where this body is, or 3 units above where this body is for this anchor. And keep in mind, if you want it to be relative to where the bodies are, you need to specify that the X and Y are the player X, because this is on the same X, and then player Y, or I'm sorry, box A dot X, because they're the same X, and box A dot Y plus the length that you gave it. So just keep that in mind. If you were to say 0 and 4, it would put it in world center 0 and 4 units up from the world center. So it's not relative to where these bodies are. You have to specify it to be relative to where these bodies are. So I think with that, just a general understanding of how this pulley structure is set up, we can jump into the code now. If you've seen from a previous video, I just have these body static box builder methods. I supply an X and a Y, and that does get converted to meters. So my Box2D units, every meter is 32 pixels. So this is essentially 2 pixels to the left, or I'm sorry, 2 meters to the left and 0 meters up, and 2 meters to the right and 0 meters up. And then I have the width and height. So this is a 1 by 1 meter box and a 1 by 1 meter box here also. You can ignore these other variables, they're not really important right now. They're pretty much just whether or not they are static or dynamic bodies. And then I also set some linear damping because I don't have the gravity turned on, just so I can influence these bodies myself. General setup I have for all these joint videos going. With that, I also have a target, which is another Box2D body, and that's just a basic almost meter by almost meter box with a lot more stricter linear damping, and that's the one that I control with some simple GDX input ISKey pressed controls. And so other than that, that's what we have going here. I'll actually run it real quick so you can see the initial setup when we first enter our world. I do call that box, or that method here, build pulley joints, but nothing happens in there other than builds these boxes. So this one in the center is the one I can control, and I can push these boxes around in any way I want. And so that's how I'm going to demonstrate how the pulley joint works in the Box2D world. So let's get into building that joint. There's 3 essential things as usual in all joints, and that's going to be initializing the joint definition, choosing the 2 bodies that you're connecting, and then creating that joint into your Box2D world. So we're going to start with the pulley joint definition, and we're just going to call that pdef equals new pulley joint definition, and we can close it off like that. And next thing you're going to want to do is, like I said, set the 2 bodies that you want to use, and we're going to be using this body A and body B here. So that's going to be pdef, and you can use the public variables that are available in most joints, and that's going to be body A equals our body A up here, and then pdef.body B equals body B. Okay, and then last thing that you'll want to do is create it into your world. That's actually world.create joint. Just like you notice there, create body. You send it the pulley joint definition, and you're good to go. And also, let's say you want to destroy this joint at any time or keep a reference to it. You'll notice I have this pulley joint variable called PJ. What this world create joint method, it actually has a return type of a generic joint, and keep in mind this is working with what's called polymorphism. So it returns a generic joint that is actually classed as a pulley joint, so you can explicitly cast it to a pulley joint and get the reference. So PJ equals let's f pj equals pulley joint, and when you cast it like that, you're all good to go, no errors. And now anywhere else in your code, because this is kind of a global variable of this class, I can do anything I want with it. I can say pj dot, I can get the ground anchor location, I can get the length of either A or B arm, I can get the current ratio, and all these other nice little variables and information about the joint. But in this video, we're not going to do anything like that right now. We're just going to create the joint. Be aware, however, this joint is a little bit more particular in how you set it up. It has a lot more variables to work with. One, as I said, being the fact that you need to establish a ground anchor alongside setting the local anchor. And for some reason in the documentation of these pulley joints, you'll notice that there's the default values for the local anchor B and local anchor A is set to -1 and 1, and I honestly have no idea why that is set like that. I mean, if someone could fill me in, that'd be great, but for the most part, I tend to use my pulley joints on the center of my Box2D bodies, or at least on the outside. I don't know why they assume your box is going to have it anchored on the right and left of the bodies, but who knows. Getting back on track, like I said, although these are the primary steps you need to get a Box2D joint set up, this one is going to come out a little weird when you just leave it. And you'll notice like we get some weird outcome here when I rub up along these boxes. It's vibrating. It's because they're having some displacement issues and they're inside each other also. So let's jump into a few more variables of the pulley joint definition. First one being the collide connected. We're going to set that to false. This variable is used to determine whether or not the two bodies still collide with each other once they're joined. And this is kind of a nice variable because we get to determine how the bodies interact. Typically in most joints, the bodies will stop interacting with each other. So if they collide in any way while still being attached by a joint, they just kind of go through each other. So this kind of gives you that ability to control whether or not they are still able to act on each other, or let's say like an arm swinging from a side view of a player is able to just kind of swing through the player body. Then you can just set that to false. So that's just a nice small Boolean you can mess around with. So then we also have the local anchor A, and you can set these like vectors, and we're just going to set that to 0, 0. Like I said, I don't know why they're offset, but for the time being, I want to set them to 0, 0. And then we also have the ground anchors. Or you know what? I'm going to wait before I add those in. I'm going to set the length. So if you remember from my drawing, you need to explicitly state how long these arms are that are attached to the bodies, and that will determine how far like the maximum length a single arm can be. So it's good to set these also, and we're just going to set those to 4 for both of them. So length B equals 4 also, and those can be floats and whatnot. So that's going to be 4 meters, by the way. This is in Box2D units, and so let's try running it one more time and see what we get. Okay, so now we actually have some interesting output here, and we actually are able to influence these the way I want to show you guys from this point of view. So if you'll notice, like I can push on this box and you saw this one here kind of extend out, and that's because the length of this one gets shortened, and so it pushes this one out. And that's how you can kind of observe how the pulley works on its own. And they don't extend anymore. Like I said, that is a constant value. You can't push beyond that length. But here's another thing, and this is what I wanted to describe to you guys. When you bring that all the way to 0, you get some bad behavior with the joint. And you'll notice how before I was able to push on it and things were all fine and dandy, but now when I push on this box, it's not moving anymore. It's just stuck. That is because this length of this arm has become 0, and it loses its reference angle of where it's supposed to extend, and so it can't extend anymore. And that's why you want to have some kind of like barrier to make sure it doesn't reach that 0 point. Just even put a circle on that ground anchor area and just like attach it there or something. And that way you can really prevent it from moving into that 0 position. But once you move it out of it, once you actually move the body that was at a 0 position with some angular momentum or something, or not angular momentum, but linear force applied to it, it'll unlock it from that zeroed out area, and you'll be able to interfere with your joint again, just like normal. So that's just something kind of important to note. Just be aware that 0 is very bad for the pulley joint in any circumstance. So you notice that when I first ran it, it wasn't really what we had in mind, like with this picture. We want something that's pretty squared off, and this is where the ground anchor comes in. You'll remember I said those little nodes in the corners here aren't visible, they're just still lines, and in order to set that, this is where the ground anchors come in. So you can go to ground anchor, that's going to be a.set, and we're going to set this to -2 for A, yeah, and then we're also going to set it 4 up, and the same will be for ground anchor B, and we're going to set that to 2, 4. So the reason I set these particular coordinates is because, like I said, I have this set to -2 meters to the left and +2 meters to the right, and this is going to be -2 meters to the left and +2 meters to the right, so it'll move where it was originally here before, out to the specified location. Remember, this is all world relative, so if you wanted it to spawn wherever your player was at that current moment, don't forget to add like body A or player A dot body -2 and all that kind of particular structure to define the actual location in your world, rather than world 0 -2 and world 0 +2. Always good to be aware of where these are going to position things, because you won't always be working with your ground or your world center. So with this, and to explain why I set these to 4, because I want to set these up the same way this picture is set up, I set it to 4 because our lengths are 4. So that'll set it 4 above where our boxes are, and that'll kind of even out the lengths, and we won't have any weird angular issues. So with this, I think we should be able to get the picture that we have on display. And there we go, perfect. That's exactly what we were going for. So now when I push on these, you can see that behavior working just the same way before, and you can push them and rotate them and all that jazz. And we can get out of there. And there's one more thing I want to show you guys before we get out of here. And that is the ratio variable. So by default, this is set to 1. This will allow you to implement a sort of block and tackle setup. And if you don't know what that is, you can look up the definition for pulleys and physics and whatnot for ideal pulleys and all that. But this is a little bit more complex. You probably won't be using this in more than very specific locations of your game, but with this you're able to control how much one block can influence the other block's arm. So like I said, think of this as like a pipe. So you're pushing this arm into this pipe. So if you set this to 0.25 for the ratio, it is saying, okay, this block, anytime it's pushed in, only push out a quarter of what was pushed in. So this will only come out a quarter of however long this arm is. But this arm, when this arm is pushed in, it will push out 1.75 times however much this arm is pushed in to compensate for this. I believe that's the correct amount. So essentially this can be like greater than 0 and less than 2, I'm pretty sure. I could be wrong, but just it doesn't like anything less than or equal to 0, so keep it away from that because it can't influence anything like 0. I wonder what happens if I set it to 3 actually. This is just a personal test. I haven't really ever checked it, but just keep it within 0 to... Okay, so yeah, it looks like it just has a regular kind of influence. I wonder if -3, do negatives influence that the same way? Okay, yeah, so that's actually pretty interesting. So you can have negative influence to where that one will actually retract that arm, and that's kind of peculiar. So you can get some interesting behavior with that ratio variable. So, but keep in mind it can't be 0. So that's just a big no-no with this pulley joint. But you can make it smaller and even negative apparently. So with that, I hope you enjoyed this video on the pulley joint and kind of gained a basic understanding of how the pulley joint works and everything with the orientation and positioning of the ground anchors and local anchors. But for the most part, these are all you really need to know. And if there's anything special you'd like to ask me to maybe set up, I'd be willing to do it. But I think this pretty much covers the pulley joint. So hope you enjoyed the video. Like, comment, subscribe as usual, and leave any questions in the comment section below. And with that, thank you for watching.